In this mechanics section, you're going to learn the basic principle of mechanical engineering associated with your project. So before I start, let's try to think about why are you doing the airship. Now you are going to design an airship, but do you know why? What is the purpose of doing it? So before we really think about how to design and how to come up with the mechanical body of your airship, we have to understand what we are designing for. As I mentioned, that design is an art of problem solving, and you need to clearly define what is the problem that you are going to solve. So in the define stage, you need to know what is the challenge. What is the purpose of having the airship? Do you want to go for speed? Or you want to go for control? Is there any limitation or constraint in the project? Try to think about the time period that you have. Try to think about the kind of material that you can use, and also think about what kind of tools that is available for this project. Apart from these limits and constraints, you also need to think about how to solve the problem, how to put these materials together, how to connect the electronic equipment, how to program your Android phone such that you can solve the problem. It's not to build the airship itself, but the problem is how to resolve the issues that we are facing. And after you design the body, after you think about the concept, then you start to explore what kind of information that you need, and also explore the physical stuff that you need in this project. Try to gather the tools and material and play with them before you really try to think about the solution, and also try to think about what kind of knowledge that you need in this project. So for the mechanical part, in the later sections, I will try to give you some information about the basic principles of force and motion. I will also talk a little bit about equilibrium condition. I will move on to talk about stability, how to come up with a system that is stable in the mechanical engineering point of view. Alright, think about a scenario. Now you need to build a mechanical body with electronic devices, and you want to program your phone such that you can control it remotely. Unfortunately, things will not always follow the plan. Like this. A very famous engineer once said that anything that can go wrong will go wrong. As an engineer, we want to understand why things will go wrong. In the previous case, the problem might be caused by, number one, wrong input signal. It can be a wire connection problem. It can also be a programming error. However, a more common explanation is indeed the misinterpretation of the mechanical response of a system. It is a very common mistake for students trying to resolve all the motion-related problems solely rely on computer programming techniques. Indeed, redistributing the power distribution of motors cannot totally resolve a motion problem if the system is mechanically unstable. In the contrary, most of the motion-related problems can be resolved easily by having simple mechanical modification. In the remaining time, let's look at how to come up with a stable system from the mechanical engineering point of view. So first of all, let's look at motion. Motion is caused by external force or forces acting on the system. For the sake of controllability, we always try to avoid complex motion resulting from unbalanced external forces or moments. Therefore, your understanding about the nature of external forces and the ability to set up equilibrium conditions are the keys to success in this exercise. Equilibrium is the state where there is no net force nor moment acting on the system. According to the Newton's laws of motion, a system will be at stationary condition or moving at a constant velocity if the equilibrium condition is achieved. For a free-flying object, there are 6 degrees of freedom and thus 6 independent motions: free translational and free rotational. Note that the system will always translate or rotate above the center of mass. Generally speaking, it is relatively easy to create a thrust to regulate the translational motion, but it will always end up with additional rotational motion if the thrust is not acting through the center of mass. That said, identifying the location of the mass center is always the first step in mechanical engineering design. In practice, you can always use a finger or a string to test out the balance points and thus the center of mass of your prototype quickly. And this is very important in the exercise. Try to do it as frequently as possible to give you a better understanding about where is the center of mass, and then use it to predict the motion of your prototype. So let's come back to the airship that you're going to build in this course. The typical forces acting on the airship body are the lift force due to helium balloons, the weight of the airship body, the motors and propellers will generate lift forces for taking off and for thrust in general movement. With translational movement, there will also be drag force caused by the air particles. In the situation of airship, there are 2 types of forces that you have to pay additional attention to. As the buoyancy force almost balances out the weight of the airship and the projected area is large, the airflow or the air current will play a significant part in the whole journey. So make sure that you pay attention to the external wind force or air current acting on your system. Besides, you're also going to use propeller to generate the thrust for movement, and top reaction have to be taken into account in the design process. Take helicopter as an example. The counterclockwise rotation of the rotor will induce a reaction torque, which will rotate the body in an opposite direction. This is the reason why it requires a long tail and a tail rotor to balance out the additional torque. This reaction torque will also appear in your airship design as long as you're using propeller to generate the thrust or the lift. So let's look at these forces one by one, before we look at how to come up with a stable body. The first one I want to talk about is the lift force and buoyancy. So rubber duck fishes and airships all owe their ability to float to buoyancy, the lifting power of air and water. The basic principle of this kind of lift force can be explained by the Archimedes principles. It is suggested that a body immersed in a fluid is buoyed up by force equals to the weight of the displaced fluid. Mathematically, the magnitude of the buoyant force is equal to the weight of the displaced fluid, but acting in an opposite direction. So for the situation of airship, gravity pulls on the body over its entire volume, while pressure only acts on the surface. Buoyant force exceeds because fluid pressure acting on the surface is larger at a greater depth, as you can see from the figure here. If we assume a constant field of gravity and the object is small, the magnitude of the buoyant force, or the weight of the displaced fluid, equals to the mass density of the fluid times the gravitational constant times the volume of the object. Keep in mind that the mass density of the fluid depends on the pressure and temperature. Here are the mass densities of common substances at standard temperature and pressure. Ice is having a mass density less than water, and this is the reason why ice floats on water. Similarly, for ballooning, you can see that 1 cubic meter of air as displaced fluid can provide a lifting power of 1.29 kg as STP. However, the lifting power of balloon also depends on the weight of the gas inside the balloon and the weight of the balloon itself. In that sense, hydrogen balloon will be able to give you a better lifting power according to the mass density. But we are not using hydrogen very often because it can be explosive. For the sake of safety, helium balloons are more commonly used in practice. Okay, now let's try to estimate the lifting power of a helium balloon at room temperature. We can assume that the weight of the balloon material itself is about 40 grams, and the helium balloon that you are going to use in this course will have a diameter approximately equals to 27 inches.